All right, so we got to prove that one trig identity for your last problem. I think it was problem 62 for your quiz tomorrow. And it gave you sine x plus y, sine x minus y equals sine squared x minus sine squared y. We're going to use the left-hand side, and we're going to try to do that whole, the one trig identity where it's sine of x plus y, and we break that into like sine of x cos of y plus sine of y cos of x, that stuff. So let's see if we can't figure this out here. If we take the first part, sine of x plus y, we can rewrite that as sine of x cos of y and it's going to be plus sine of y cos of x. And I don't remember exactly what that trig identity was. I think the cos and sine might be flipped, but it's still the same thing. All right, so that's the first part. And now we're going to do that sine of x minus y one. So it'd be sine of x cos of y minus sine of y cos of x. And we're going to make that all equal the right-hand side soon. All right, so now what we're going to do is we're going to really treat this as like something, a term plus a term. So you got like a plus b, and then that matches that first term, which was a, and sine y cos of x, that matches that second term, which is b. So really you've got like a plus b times a minus b, which hopefully you know the little pattern for, like the a squared minus b squared part. So we're going to go ahead and distribute everything in here. You're basically going to like FOIL this problem out. So we'll multiply those two terms together. Sine x cos y times sine x cos y is going to give us sine squared x, because we're doing sine times sine is sine squared. And cos times cos is cos squared. Really, you could do that like, I'm trying to think of a good way to know this. I mean, because you're taking like sine times sine would give you sine squared. You got sine twice. Cos times cos gives us cos squared. So when we distribute the first piece in the FOIL, first times first, that's what that would give us on that part. All right, so now we're going to do the outer terms. You got sine x cos y times negative sine y cos x, and there's no like term, so we can't do sine squared in this one because you got sine x and sine y. So it's just going to be sine x cos y sine y cos x. We have no sine squared or cosine squared or anything like that. Now we're going to do the inner terms. It's going to be positive sine x cos y sine y cos x. All those inside pieces. Now if you look, those two things are the exact same, right? That's how, hence that idea of like a plus b and a minus b. Those middle terms when we do the FOIL. So our outer, when we multiply the outer and when we multiply the inner, they end up being the same thing, but one's positive, one's negative, so they cancel each other out, which is kind of nice. And then we're going to do the last terms. So we got to distribute that times that, which is going to give us sine y, so that'll be negative sine squared y, cos squared x. So we took the left-hand side and we basically rewrote it, we distributed it, and now we're left with sine squared x cos squared y minus sine squared y cos squared x. All right, so we're almost done. We don't have it yet, but we're going to do some more trig identities. And the next one stems from what cos squared equals. Cos squared, I don't know if you know the other trig identity, it's like 1 minus sine squared equals cos squared thing. So we're going to rewrite cos squared as really 1 minus sine squared. So that's that inside piece. And we still have the sine squared over there. And we're going to do the same thing to the other side. We're going to leave sine squared alone. But cos squared is going to turn into 1 minus sine squared. All right, still more on this one, unfortunately. We're basically going to take that sine squared x, that first term, and we're going to distribute it into the problem. So we're going to take that and kind of distribute it into the parentheses. And same thing on the right-hand side. Distribute it in. Sine squared x times 1 is just sine squared x. Sine squared x times sine squared y. You can't combine those and get like sine to the fourth because one's x and one's y. So we're just going to leave it as sine squared x, sine squared y. It's like two things getting multiplied by each other. We can't combine them though. Same thing on the other side. We're going to distribute that sine squared y times 1, and it just stays sine squared y. And we distribute there. Again, same deal. We can't combine any like terms, so it can't be sine to the fourth. And it's a negative times a negative, so it's going to be positive sine squared y sine squared x. All right. Feel free to like pause this and rewind it anytime too. I know this is a very long one, but hopefully it's making a little sense. We've got sine squared x, sine squared y, and we can kind of flip those orders. That's like 2 times 3 equals 3 times 2 type of deal. One's positive, one's negative. It's the same term. They're going to cancel each other out. And we are left with our final piece, sine squared x minus sine squared y. And we are done. I think that's what we were trying to prove, right? We're trying to get all of that to equal sine squared x minus sine squared y, which we accomplished. So hopefully that made a little bit of sense for those problems. Shoot me a text, let me know if that didn't or if you need any more help. All right, good luck tomorrow.